0 and liftoff.
That's it. That was a long day. 36 hours. About 3 hours of sleep in there somewhere. Half of it on a bus, half of it on a plane. But there it is. So now the journey really begins. As we led up to that whole operation, we had a huge set of work ahead of us. Stowing the rover and getting it ready for shipment meant a lot of shifts in a row, a lot of complex operations with the vehicle. And you have to remind yourself, every time you pick that rover up, it's almost $1 billion worth of hardware that you're watching out for every time you do something with it. So that part got to be really white knuckles for us. It makes us a little nervous sometimes. I mean, you worry about the environment. It's on a forklift. It gets put on the back of a flatbed truck and then run down the highway to March Air Force Base from JPL. And that whole transport is just like you're driving any other truck down the highway. So it's full of bumps and it takes lumps and so it's one of those that you worry about for sure. It's a very impressive operation to get the shipping containers up into the aircraft. These boxes are incredibly large, and even as big an aircraft as the C-17 is, it is barely big enough to fit these boxes. There's an entire team of Air Force reservists who help us load this, led by the load master, who was in charge of the winching operation. Basically, they use the aircraft cable system and hydraulic winch to hook up to the container and tow it on board. As that happens, you have a team of about 8 other Air Force crew members, plus all of the payload crew members, all of the MSL crew members that we had with us, watching all of the corners, making sure that everything was clearing and that the measurements were right and that we weren't going to run into a problem if the shipping container got offline for any reason. Even despite the best planning, we can find ourselves in a spot where we still have to solve some of the problems. We need thick plywood to reduce the contact pressure on the wheels on the shipping container. You have this thing which weighs 10,000 pounds or more, and you have to make sure you don't punch a hole in the aircraft floor. So we had to get thicker plywood. We had to make emergency calls out here to Kennedy Space Center to make sure that enough plywood was on hand when we landed so that we would actually have that same accommodation on the way off of the aircraft.
Man of attention, please. Man of attention, please. Please remain seated with your seatbelt fastened until we reach cruise altitude. I will notify you when it is safe to move around. Thank you.
All of those operations had to be undone once we got down to the ground here at KSC, and so the operations on the tarmac, including the offloading of the shipping containers, had to be done just in the same way. The same crew then, after the 5-hour flight, stepped up and had to check all of those clearances again, make sure all of the rigging was out of the way and that the winch system was ready to help lower the shipping containers down the ramp. You didn't want it to get the shipping container to get away from you and roll out onto the tarmac get out of control. So, but they did a really nice, careful job. And again, we had all of the same crew that were there at March Air Force Base here at KSC, plus our arrival crew. We had a fresh crew of folks who are well rested to be able to take care of a lot of the ground operations once we arrived here, so that those of us who had been going for almost 48 hours straight didn't have to also finish out that part of the job. We're about to send our baby on a very long journey to go spend its life exploring the surface of Mars. And it's a big leap of faith to be able to hand off the vehicle. They have a great team on the launch vehicle side, and they're ready to take care of her. But we are definitely nervous parents.
Zero and liftoff.
One of the most challenging aspects of this mission happens before we even land, and it's picking the right landing site for the mission. We want to study the habitability of Mars. We want to really figure out if it was ever capable of supporting life. And the way we do that is to really follow the evidence of water on Mars. One of the most interesting things about Mars is that it's changed over time. What we see on Mars today is very different from what occurred in the distant past. And water is the real interesting thing that we're looking for, the history of water, how it's changed over time. One of the biggest challenges to studying habitability on Mars, which is the goal of the Curiosity rover mission, is to try to follow that signature of water. Where was the water? How long was it there? And where do we go to look for evidence of it? If we were somewhere like this, where there's a pretty obvious geologic record of water flowing, carrying material down, that would be a home run. But the real challenge is finding that one spot on Mars to send this great rover mission to. We have 4 wonderful landing sites, all very different in character. And the real challenge for us as scientists is to come to a consensus on which one of those sites offers the best chance of fulfilling the goals of the mission. There's a place on Mars called Mars Vallis, which has the brightest mineral signature of clay minerals on Mars. And these clay minerals are known to form in the presence of water and neutral pH water, not acidic, not too basic, just the kind of water that would be friendly to life. Then you have terrestrial geologists who say that the rock record should be the thing that we follow, the landforms that look like they were carved by rivers or floods. So you have sites like Holden Crater, which is a big impact crater many miles across with a river coming into it, perhaps forming a lake multiple times and flooding the crater, leaving a geologic record that we can study with Curiosity. Just upstream a little bit from Holden Crater, there's a place called Eberswald Crater. That same river system in Eberswald has left evidence of a delta. Just like the Mississippi River Delta, these things form when muddy, silty water deposits its silt, its mud, into a formation, into a standing body of water like a lake. And so you have people that study deltas on Earth who think that's the place Curiosity should go. The final site is the best place on Mars if you want to just study layered materials. So why do we like layered materials? Because just like this outcrop behind me, they give a record of time, of how things change over time. By studying different layers, you can rebuild the geologic history of Mars. So there's a place called Gale Crater, which has a 3-mile stack of layered rocks. Now we don't exactly know how those layers formed, and the mineralogical evidence isn't as strong as other sites, but people who just think layers are the thing to study really love Gale. So you have these 4 different sites and these 4 different groups and very passionate arguments back and forth to try to really narrow in on what is the one site to send the Curiosity rover.
One, zero, and liftoff.
We are wrapping up the last of the vehicle test and get ready to make it a real spacecraft here before too long. It's going to be a big push, but that's kind of how the end game goes. We try to get things ready and every last thing has to be done and done right. It takes a lot of time and a lot of effort to do it.
We have a lot of work to do in the next 2 months because although the vehicle's in Florida and we've stacked it together just in the last couple of days, the rover's got its rocket jetpack on it, and the jetpack and the rover together have been put in the back shell of the vehicle, and right now we're putting the cruise stage on top. In some sense, that process is actually pretty straightforward. The challenge we have here in Pasadena is finishing up all our testing. All of our testing in our test bed and on the equipment, and going through and looking all the problems we had in our test program, make sure that all the problems we found were all solved and that we know what we're going to do and how we're going to fly it.
3, 2, 1, fire. Everyone stand by. Rover deck.
Testing is a lot like renovating your house. You can enumerate some very large, obvious things to do, and then when you do them, it becomes clear that there are some secondary things to do. And then when you do those, you discover third order, fourth order, ad infinitum. We require our system to be able to be robust, to survive a number of different kinds of faults, both internal faults, things breaking on the spacecraft, or loss of sun data coming into the sun sensor, a variety of unfortunate circumstances we try to make our design robust to.
Not only have we driven the rover, we've moved its arm, put it all through its paces, but it's been in a thermal vacuum chamber and kept very cold. Parts of it have been in a centrifuge. We've done drop tests, pull tests, drive tests, load tests, stress tests. It's just an amazing amount of testing this vehicle has gone through. We've done shorting tests. We've taken the vehicle and shorted electronics. We've looked to see that the radios all work together and that the rover doesn't interact with itself in bad ways. We've tried every way of operating the vehicle using the software, literally thousands and thousands of hours of software testing. It's been just an amazing several years, really, of constant testing and development, finding problems, fixing those problems, and going on to the next problem.
The system is sufficiently complex that anything you change has to be done with great care and caution, and then tested thoroughly because of the potential for side effects, unintended consequences of the fix. The first rule of engineering this late in the game is do no harm.
This is a very, very complicated beast. This is by far the most complex thing we've ever built. It's almost hard to imagine how complex it is. And in fact, if you get close up to the vehicle, you can see the richness of detail. And in fact, this vehicle almost has fractal-like complexity. The more you look at it, the more details that you uncover. And you have to make sure when you're building this thing and testing it and designing it, that those interactions are well understood and that there is nothing about the system that will interfere with itself. And this has been a real challenge that we've had. And so every minute of the time we've had, we've been using that time with incredible intensity. So hopefully we'll take a big breath in mid-November before we launch and be able to relax and let this vehicle off the ground and finally say goodbye. I think she's ready to go.
There was this really amazing moment at the end here when we were looking over the rover one last time and making sure that what we were seeing was good for flight. It's that final moment you spend with the vehicle. That last sanity check. Does everything look right? Is anything out of place? Is it really ready to fly? Because we're about to send our baby on a very long journey to go spend its life exploring the surface of Mars. It's a big leap of faith to be able to hand off the vehicle. They have a great team on the launch vehicle side, and they're ready to take care of her. But we are definitely nervous parents.
It's a very happy and sad day when you launch her. It's very much I equate it to, say, having your daughter get married. We basically brought her into existence, we powered her up, we spoke to her, and our team understands how she reacts, her emotions, her idiosyncrasies. She's been ours all along, and now I'm going to hand her off to the next team and they'll get to run her. They've always been on deck waiting for us to get out of the way.
Confirmation that would go for launch at this time. Go ahead and scrub. NLM confirmed.
As launch approaches, of course, the pressure does ratchet up and you start to worry, did we think of everything that could possibly go wrong? Do we have all of our procedures ready? There are a lot of what ifs, and you question yourself and your team, are you ready to handle this? But ultimately you know that you've been trained to do this and you are ready to do this, and you've got a great team around you and a great spacecraft ready to go. And you ask if I'm nervous, the answer is absolutely I'm nervous. Am I confident that she's going to go and she's going to be successful? Absolutely. It's going to go and she'll be good.
The other day we closed the 2 hatches up on the Atlas, and I was able to touch that. I was able to touch the rover when I disconnected the purge from the rad system, and that was kind of an emotional thing, you know. Almost turned around and walked away from it, and QA was like, Dylan, wait a minute. This is the last time you're going to be able to touch this thing. And I'm like, really, that's true. So I'm over there stroking it like a little puppy and had to walk away from it, and to realize that it's almost done and then it's ready to go. You're almost kind of disappointed it's over with, but you're ready to move on to something else. And I'm ready to crack that champagne open when that thing lights and goes, and then we got to wait till August of next year to see it do its business, and that's what it's all about. So yeah, it's a great feeling.
There's this golden couple of weeks that happens just before launch, which is that we're really kind of done testing. We're done encapsulating the vehicle. It's now part of the launch vehicle provider's job to get it integrated and mounted on top of the rocket. And as far as the spacecraft goes, it's kind of quiescent. When you see what a rocket really does in practice, it's an amazing thing when it works.
The launch team's really excited. So this is very difficult this morning. Launching something from the planet is really hard. Now we make it look easy. It's not.
Rocketry is still a less than perfect business. Failures do happen. You kind of have to make your peace with the notion. It's like a suspension of disbelief, meaning that in order to get through it, you have to believe that rocket launches can only go perfectly. The good news is almost always they really do, and it's really a thrill when it's over.